Right, recording started. So, kids, um, right. So today our lesson is logic gates. Let me first of all explain our plan as usual, because every class I have to explain the plan so as you stays on track. Right? Quickly, let's see where are we now. Are there any newcomers? Drop me a message, kids. Are there any new? First of all, I want to check. Are there any people who have come to this class for the very first time? Are there any comments? Drop me a message. Hmm. Uh, yeah, yeah. Okay. Iman, Madhu, Bash. Okay, let's start. Okay, Namai. The newcomers, if you know, drop me a message quickly. How many lessons are we having for A level ICT? How many lessons are we having for A level ICT? We have quickly drop. Yes, yes, yes. 13, 13, 300 units. My God, nature. We have 13, we have 13 units. We have 13 units, right? So, first lesson, we already completed concepts of ICT done. Second lesson, evolution of computers done. Here, 4 videos available on our website. Any student who are enrolled into my classes, they will get this first lesson 4 videos for free, right? Available on YouTube as well, right? Drop me a message, I'll send you. Second lesson, you have to enroll to the class, dear. Then you can, if you are a pure online student, you can pay and purchase lesson number 2. If not, enroll to my physical classes. You can get all the online classes free, right? After that, it's also done. Then my third lesson, which is number systems, a mathematics lesson. Better to have this knowledge to proceed with logic gates today's seminar as well, right? So this lesson also we have already completed. So as I promised, I took 4 sessions here, I took 3 sessions here, and again here also, as I remember, I took 4 sessions, right? Did I took more? No, ne? I took 4 sessions neither. So as I promised, my time according, you can see the times are exactly right as I am predicting so far. All the times was timing was correct. So today we are starting fourth lesson, lesson number 4, which is logic gates. We are starting logic gates lesson. Okay. So any student who wants to know more about the classes, first of all, I have to inform this as a procedure. I have to tell this because this is a seminar and new students are in the meeting. I have to inform this one. If you are a level 2028 student, our normal usual class is on this time, Friday, every Friday, 7:30 to 10. That's our normal class time. Physical class is on Sunday, 2:30 to 5 o'clock. Paper class will be adding up until 6:30. That is the time range. All my physical class students gets the online classes free, so they are covering the syllabus twice, right? And if there are 27 batch students, you also can pay for the 27 batch classes. You are getting all the 28 batch classes for free of charge, so you can cover up with the missed sessions without any additional cost. So those are the advantages that you are getting in PRIME ICT program, right? So if you want more information, Lamai, you have to visit my website, primeict.lk. This is my personal website where you have a personal AI assistant. He will help you. He will guide you how to join to my classes. After that, to enroll, you should register into eduzonecollege.lk. To register into my classes, you should enroll in eduzonecollege.lk website, create an account, then you can browse the lessons and purchase, and I will guide you. There's a video uploaded explaining you how to use this website as well. That's also there. Harid. So that's our process. We are running on a plan for all the 13 lessons. I have proper plan and we are going through this. So every lesson starting, I will be publishing a seminar. Better to stay joined in the groups, WhatsApp groups. If you are not yet in the WhatsApp groups, you can find the relevant WhatsApp groups. Come to this website. In this website, Huda, I have mentioned all the WhatsApp groups listed as blocks. You can scroll and select the relevant group for you and stay there. When I will publish any free seminars like today's one, you can join without any problem. So that is our plan. Is this okay? Right? Okay. Then so Logic Gates PDF other. I will share the PDF after the session because today the Lamai, every lesson has a way of teaching my own. Number systems lesson, I had a separate approach. First two theory lessons, I had a separate approach. Like that, logic gate lesson also, I should have a separate approach. I should have a way of teaching. So this lesson, I am expecting you to maintain the note, but I will give the note also. Don't worry, I will be giving a short note. But I want you to maintain a nice note, a short note like thing in this logic gate lesson also. Right? Logic gates is a skill, not a lesson to study and repeat and learn again and again. Logic gates is a skill you need to develop, like coding. So I want you to develop that skill, not to by heart the theory stuff. There's no any theory stuff. Just don't by heart. There's nothing to by heart. So if you are good with logical thinking, you will be okay with this lesson very easily. Hurry. So then that's all about the marketing, branding and all. Let's start our lesson today. Fine. Okay, I will erase all these. Right. So kids, hope I am very audible. Very clear, neither. You can clearly see me, clearly hear me. If anyone is not hearing me, drop me a message quickly. Hearing, right? Yes, okay. Right. Take out your writing books, dear. Take out your writing books. Take out your pens, pencils, and better to have some color pens also. Right. I also have multiple colors. So if you are working in a neat manner, you should have those pens. Ne? There's nothing different between girls, boys, and you guys. There's no difference. Just when you're working, maintain your notes neatly. That's very important when you're studying. Huh? It will be giving a good impression for you to study. Right. Let's start. Kids, in this lesson, you're going to study about a small, let me give you a small introduction. Logic gates is a lesson that you are studying the fundamental parts of how the computer works, how the computer operates, how the computer execute its programs. For an example, I can explain you like this. From logic gates, you can arrange a flow of data, a process like your hard coding. You're arranging a flow of data so as your system runs on that exact path. Right? So now you won't understand anything. So I need to give an introduction. That's why I just said about logic gates like that. Logic gates is the fundamental basic unit, how the circuits, how the ICs are prepared. Now tell me quickly, which generation we found integrated circuits? Which generation we found integrated circuits? Lesson number 1. Drop me a message. Yeah. Okay, generation 3. So in these ICs, those ICs developed. And now these ICs has logic gates inside it. You can purchase logic gate integrated ICs in Beta. You can buy it. So it has like this. If you purchase the IC, it has logic gates inside it. It's not big like this. It's very small. I can show you a small image how this IC look like. Wait, will you? I will show you. Right. ICs. These are the ICs. So inside these kids, we have logic gates. Like this, we have ICs. Inside these, we have the logic gates. Now how? Like this, very simple. Something like this. I still didn't start at the lesson. I'm still giving you a small introduction. Like this, we have these pins are connected to the gates. Like that, we have ICs. Now you don't know what is this IC. You don't know what is this gate. You don't know anything. Let me teach you step by step. I'm just giving you rough ideas, and these things you will understand when I'm teaching. When I'm going forward and when I'm explaining the things, you will understand what are these gates, what are these ICs, what is the process of this, why are we having this. You will be getting all the answers for every question that you are getting. Right, okay. Let's start. Lamai, in logic gate lesson, the real job is, let's first of all have a mind map. What are we going to study? You are going to study, we have three things. We have three things in logic gates. You have logic, gate, diagram. You have logic, gates, diagram, right? So I'll box it. Then you have Boolean expression. You have Boolean expression. Then you have to find truth table. You will learn what are these. If you are an O-level ICT student, you already know what are these three. But if you haven't done any O-level ICT subjects before, then you don't have any idea on these. These words are new to you. But don't worry, don't get scared. These are very easy things. Logic gate diagram lamai is a diagram as it says. It's a diagram as it says. Your job is to find when the diagram is given. In the questions, they might give you the diagram and ask for the Boolean expression. They might give you the Boolean expression and ask for the diagram. They might give you the Boolean expression and ask for the truth table, or else the logic gate diagram to the truth table. And from the truth table also, you should have the skill to find the Boolean expression. So these are the things you need to find in this lesson. But not only that, you have something more. It's not ending there. Listen. Here, when you are converting from truth table to the Boolean expression, you have to deal with two methods. First method is SOP. And second method is POS. Now, these words are new to you. Don't get scared. I will teach. Right? SOP and POS. After that, what are the other things? Okay, Boolean expression is there. You have to have the idea in A-level syllabus. You should have the idea to simplify the Boolean expressions. I'll write it in black color. Take a black Indian now. Simplifying the expression. You should have the idea to simplify expressions. For the simplifying, you have two techniques. One is Boolean, hope it's visible, Boolean laws. Boolean laws. Second one is, kids, you should follow the Kano map, right? So those are the two techniques you have to follow. And also, what are the other things? You have to know these stuff. Wait. Some other things are there. Half adder. Half adder. Then you have to learn about full adder. Then you have to learn about flip-flops. Flip-flops, right? This diagram also you are going to draw with Boolean gates. There also you have two types of gates, right? There also you have two types of gates. First, normal combinational logic gates. Let's say normal for your understanding. Then you have universal logic gates. Universal logic gates. I will explain you what are those as well. So put the topic, kids, in your writing book. Lesson summary, right? This is our lesson summary. These are the stuff you are going to learn. Our first step is learning this one. Our second one is learning, first step is learning this one, Medical. Second step is learning this. Third step is learning this. Fourth step is learning this. Fifth step is learning this. Make a fourth. This is fourth. Make this fifth. This is sixth. Then these are after that. 7, 8, 9. Those are the parts that we are going to learn in this lesson, right? Quickly write this down in your writing book. This is our map. This is our summary. Quickly note it down, dear. Yeah. Is this a big chapter? Yes. This is one of the big chapter. I need nearly around 2 months to cover all these. So see the things that you need to study. Today we are completing this first part, right? And the second part, and also the third part. Then upcoming weeks we will be doing these. And this one, half adder and full adder and flip-flop. I have done a nice video. I will be releasing the video of them. We don't want to waste another session. I will be adding the videos to the lesson, and that will be this is a very small area and they won't much questioning on this part. But even though if it is questioning, I have done a very good detailed video on that. I will share that also. So then we can save some time. Other parts I will be teaching you live, right? So this is our plan. I'm going to give you 5 minutes exactly. Can you quickly note it down? Right? And drop me a message. Once done, drop me a message. I'm waiting for your response. Quickly note it down. This is our summary. So take your writing books. Stay focused in the lesson. Those are the stuff that I don't want to teach you again and again. You're done. And nicely do, huh? Can tell those simply again, please. Okay. Quickly, I will explain these things. In this lesson, we are going to learn about logic gates. So here we have logic gate diagram. You need to learn how to convert this logic gate diagram to the Boolean expression. Today I will teach it. From the Boolean expression, you should have the knowledge to find the truth table. From the logic gate and Boolean expression, you should be able to find the truth table. And since we are in A levels, we are learning from the truth table how to find the Boolean expression also. You didn't do this part in the O levels. You did this one, and this one. 2, 3, and 4 you did. You didn't do this truth table to Boolean expression in the O levels. But don't worry, I'm still teaching from zero everything, so every student can understand it clearly. So to convert this truth table to the Boolean expression, we have two methods. One method is SOP, another method is POS. This is the part you are spending most of the time. This is the part you are spending most of the time in this lesson. Hurry. And also here, Boolean expression. Once you got a Boolean expression from a logic gate or a truth table, you can get me. Here also you can get, here also you can derive Boolean expression. After that, we should follow some mechanisms to simplify the Boolean expression. We have two methods to do that. We have Boolean laws method. We have Kolonnawa map method. We have two methods to do those stuff, right? And also another thing, මේකත් පොඩ්ඩක් side එකෙන් දාගන්න. You should learn. I will write it here. Hope it's clear if I write it there. Yeah. We will be learning about SOP, POS, standardization. Standardizing කියලා දාගන්න. SOP, POS, standardizing, and conversions. Conversions between SOP to POS. We are converting the POS equation to SOP equations. You don't understand if I'm saying that those things right now. Give me time. Just write the stuff. I'm just giving you the map. This is just the mind map for you to follow up. So when I'm teaching, you know where am I now. Okay? Using this map, you can follow where am I teaching now. So drop me a message once you're complete with it. Complete color message done. I'm waiting. What is SOP and POS? I didn't explain it. Right? SOP means sum of products. POS means product of sums. You have to wait until that comes. So today I'm not going to teach you these parts directly. Everything is step by step. Follow the steps, trust the process. You will be learning everything on time. Right? Okay, what else? What is the full form of K-map? K-map means Kolonnawa map. If you want, you can write. K-map means Kolonnawa map. K-A-R-N-A-U-G-H-M-A-P. Kolonnawa map. Right, okay, fine. Shall I start then? Done. Nihila done. Well, others, drop your message. Right. Altaf done. Right, others, I'm waiting. Make it quick. At least another two, I will start. Don't wait like use this time. Don't keep another time for this. Write it down and finish it off. Done. Abdul Hakim, very good. Others? Zain? Zain, Tashishi. Where is Janani? Is she yeah, done? Okay, Chanli done. Right. Abdullah, Iman, Amar, Tashishi, all the others drop me messages. Right. Okay, very good. Very good. Done. Okay, right. Very good. Right, okay. Very good, Harry. So, let's start. Hope it's clear. Right. Then I'm clearing. Right. Okay, then. Right. Now, let's get an idea about what are the gates that we need to learn for our lesson. One second. Right. Clearly. Right. So, when we are talking about our normal combinational gates, we have two types, combinational and sequential. Let's first of all have a rough idea about the normal gates that you have. This is one gate. This is a one gate. This is another gate. This is another gate. Yeah, let's write this one. This is another gate. These are the four main gates we have to study in our A-level syllabus. Four main gates. I am still not in the universal gates. These are just main gates. Okay. Lamai, can you see these ones? To develop the real idea about this systems, the logic gate system, are to develop autonomous systems, smart systems, autonomous systems that they automatically sense the output, sense the input from the environment. These gates actually can, the systems that we are making from these gates actually can sense the inputs from the environment and act accordingly automatically. That is the main idea. For an example, assume you need a security system to your home. You need a security system to your home. When a thief is coming, on a Zuha is the thief. This is Zuha. This is Zuha. On Zuha is the thief. Right? Now the Zuha is coming to your home. Zuha is coming to steal your laptops, your mobile phone, and digital items. Now Zuha is coming. When Zuha, the thief is coming, you should have placed a motion sensor. You should have placed a motion sensor in your home. Motion sensor. You have a motion sensor, right? And also a switch. You have a switch also. Your security system is turned on. Switch is turned on. Now, motion sensor is off. Why? No one is near the motion sensor. Motion sensor is turning on when the Zuha is coming near the motion sensor. When someone is coming near to the motion sensor, this off signal turns to up signal. This off signal we are denoting in 0 in ICT. Zeros and ones, everything. So off signal means 0 here. Then when the Zuha is coming near to the motion sensor, what happens? Quickly, this 0 signal turns to signal on. On means 1. That's the basic idea. So we can connect this motion sensor to a wire, to our logic gate. We can connect our motion sensor through a wire to this logic gate. When the motion sensor turns on, listen carefully, when the motion sensor turns on, what happens? This will trigger, this will send one signal through this wire, right? We can plug an alarm to this output. We can plug an alarm to this output. So when the signal is coming here, that means Zuha is near the motion sensor. Zuha is trying to enter into the home. What I am doing, my output should turn on. That means, kids, when this motion sensor is sending one signal from this gate, I should send the one signal to the alarm. When the motion sensor is sending the 0 signal, that means no one is near the motion sensor. Motion sensor, what is his job? When someone is moving, he can detect. If someone is moving, he can turn on. He can generate a on signal. He can turn on. It's right. So he's sending the on signal here. When the on signal is coming, I should send alarm on. Then alarm, when the alarm is getting the on signal, what happens? Alarm is making a loud noise. Easy. Is this concept hard? Kids, may concept if you don't understand this concept, you won't understand this entire lesson. Drop me a message first. This is our main job. Based on the environment change. What is the environment change here? And Zuha came near the home. How did we detect the environment change? From the motion sensor. From the motion sensor, how did we detect? He detected the movement. Motion sensor detected the movement. Suddenly, he turned his off signal to on signal. Initially, it was set at the off signal, mutta, right? Once the Zuha is coming here, it turned to the on signal and started sending on signal to where? To this AND gate. And I don't draw this. May here, co-host, please erase this. Sorry. May he starts sending the on signal to the gate. Gate, what it does? It sended the on signal directly to the alarm. And now you have several questions. Like, sir, why didn't I directly connect this motion sensor to the alarm? Why can't I directly connect? No, you can't directly connect. Think every time it is starting to alarm starting to on. Assume your father also coming, when the mother also coming, even when the dog also coming, the alarm starts to turn on even in the daytime. But you need this system only in the night time. Assume you need this system only in the night time. You don't want this to activate alarm every time in the daytime also. Then I can connect this switch. I can connect this switch to this gate. I can say, when this switch is on only, when the switch is off, don't work. When the switch is on only, work with the alarm. Like that, through this gate, I can prepare a process. I can prepare a process. Drop me a message, kids. Is this clear? Is this clear? Drop me a message. Yeah. Iman, can you explain once again? Yes. Okay, sure. Wait. Yes, understood. Crystal. Okay. Okay, man. What is the idea was, we can plug sensors and switches to our logic gate circuit. We can plug sensors and switches to our logic gate circuit. Whenever the sensors or switches are off, it is sending 0. 0 means off signal. Whenever any of the sensor or else any of the switch is turned on, it is start sending one signal, sending the signal number 1. That means on signal, on. When the relevant sensors are sending the relevant signal, our logic gate decides to do the output based on the signal coming. That means when the motion sensor is turned on, when the Zuha is trying to enter into the house, I can program this logic gate set to turn on the alarm. Assume I have several set of alarms. When the Zuha is entering the back door, I can program from this logic gate to turn the alarm on the back door. When the Zuha is entering in the front door, I can turn on the alarm in the front door. Like that, I can program a set of processes using this logic gates. That is the basic idea of the logic gate. Is it clear, Iman? That was the basic idea. So these are wires. These are wires. What are we getting to the logic gates as signals? One of them is zeros and ones. Right? That is the thing you should remember. Yeah. Okay, right. Very good. Okay. Then, listen, will you? I'm going to erase this. Right? I'm going to erase this one also. Right. Okay. See here. I am going to give some names. These are the names, right? This is called AND gate. This gate is called AND gate. This gate is called OR gate. This gate is called XOR gate. This gate is called NOT gate. These are the 4 names for these gates. So these are what, Lamai? In here, these are what? These are what really? Input wires. You can mark it. Input wires. These are input wires. Input wires. All these 3 gates, Lamai, can have any number of input wires. That's why I put 2. 2 means not only 2, you can have more than that. You can have more than 2 input wires for this gate. But only for this gate, it is limited to only one wire. Limited to only one input wire. Only for this NOT gate. Other gates are having multiple wires. Remember that as well. Right. Each and every gate is performing a mathematical operation. Okay, fine. It is not actually a mathematical operation, but in your syllabus, we are not focusing on that deep understanding. We are focusing on the application level of the logic gate. So I am saying AND gate is doing something like multiplication. OR gate is doing something like addition. XOR gate is doing something like I don't want to explain it here. I will explain. Give me time. Not here. It is doing a process, not like addition and multiplication. Plus circled. We are writing it as plus circled. NOT gate is working as an invert, a change in the incoming signal. So this is what happening, Lamai. Assume you are connecting. Now listen carefully. Stop all your other works. So now assume this motion sensor is connected to this AND gate like this. Motion sensor is connected to the AND gate, right? Now when the Zuha is coming, motion sensor turns on. If the switch is turned off, it is generating the 0 signal, right? When the switch is turned off, it is generating what signal? 0 signal. 0 means no signal. It is 0, right? When the Zuha is coming and the motion sensor turns on, he is sending 1. Lamai, this gate, if the gate is AND gate, my operation is happening like multiplying. So tell me, here I am getting 1, here I am getting 0. What is my output? What is my output? 0 or 1? Drop me a message. Will my output be 0 or 1? Tell me. 0. Very good, Neela. 0. 0, 0, 0. When it is multiplying, it should be 0. Okay. If it is 0, if that is 0, if I am connecting to the alarm, this output wire I am connecting to what? Alarm. Now tell me, switch is off. When the motion sensor is sending 1, Zuha is trying to get into the house. But will the alarm turn on or off? Alarm stays on or off? Tell me now. Drop me a message. On or off? On? How on? AND gate is acting like multiplication, as I said. So we are getting 1 here, 0 here. 1 into 0, 0. 0 means lamai what signal? 0 is lamai what signal? 0 can what signal? Yeah. Off, 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 off. She is coming inside. Yeah, she is coming inside. But the switch is off. Switch is off. So the alarm is not working. Alarm is lamai off. Alarm is off. If we are using AND gate, that is what happening, right? Okay, assume switch is also on. I turn the switch on before I'm sleeping. Before I'm going to bed, I turn the switch on. Now the Zuha is coming. Now when the Zuha is coming, now before the Zuha is coming, see the scenario, before the Zuha is coming, our motion sensor is generating 0. That means what? 0 from the motion sensor. Switch is generating 1 signal. Our AND gate acting as a multiplication. AND gate act as multiplication. That means 0 into 1 again. My alarm is still off. Alarm is still off. Now what's happening? Zuha. Now Zuha is coming. Right? When the Zuha is coming, this motion sensor detecting this scenario. Right? I'm erasing this signal. Now the motion sensor is triggering 1. Now the motion sensor is triggering 1. Now tell me what happens. Motion sensor sending 1. Switch is sending 1. What should be my output? What should be my output? Quickly. On. My output should be on. On means lamai. Now what happens to the alarm? What happens to the alarm? Alarm turns on. Alarm turns on. Understood. This is the scenario we are going to handle. Now, this is not like this naturally, it's not easy as this. As you see, A-levels need more complex gates. A-levels, we are dealing with more complex gates. Again, the gate, we can join the gates with these wires. These are wires. We are joining the gates with wires and we are building a bigger circuits from the gates. We will be doing it later. Haridha. So, yeah, a lot of questions are here. Tashishi is asking, okay, send in private. Okay, Hari, all the answers are correct. Right, correct, all the answers are correct. Right. Okay, kids. Okay, before moving forward, let's see. What if instead of you are using AND gate, what if you use a OR gate? OR gate is acting as a addition now. Let's try an OR gate here. I'm connecting my motion sensor to the OR gate wire and switch also to the OR gate wire. Now tell me this. When the motion sensor is 0, switch is also 0. What is my answer? Motion sensor also 0, switch is also 0. Both are off. Off me. My go gate output which I am connecting to the alarm. Now I am connecting this one to the alarm. Hurry. Now I am connecting this OR gate output to the alarm. Hurry. Now my alarm is off. I am turning only the switch. Switch එක විතරක් දානවා. I am turning on only the switch. And now tell me, what will happen? My alarm. What will happen to my alarm? Yes. Alarm 1. Alarm turns on, right? Alarm is turning on. Why? This gate is acting not like AND gate. It is OR gate. OR gate supposed to add the two inputs. What are the two inputs? 0 is coming here. 1 is coming from here. 0 plus 1. 0 plus 1. Answer is 1. So 1 means I know. 1 means I know. 1 means on. So the alarm turns on. In this setup, if I use a OR gate, what happens? I can't get the real use of the motion sensor. Just because I turn on the switch, my alarm starts to work. Even though the alarm is off, assume the switch is off, my motion sensor detects Zuha is coming to the home. And my motion sensor detects Zuha is coming to the home. Now what happens? Since this is OR gate, just because the motion sensor sending one signal, alarm starts to work. It's not considering the input of the one other switch. Understood these two gates, how it is behaving. Understood these two gates behaving, right? Okay, very good. Now let's see all the possibilities of these two gates first before moving to the OR gate. Right? Before moving to the XOR gate, let's find all the possibilities. I'm erasing all these. Right. Okay. Now, assume, tell me what are the possibilities you have here. Really, if you have two wires here in this AND gate, I have two wires here, wire 1 and wire 2. It is hard to say wire 1 and wire 2. I will name it as wire A and wire B for easiness. I will tell this one as wire A. I will tell this one as wire B. Okay, let me tell the inputs, wire A and wire B. Assume my wire A connected sensor or the switch is sending me 0 and B also sending 0. What should be my output now? What should be my output now? What should be my output? Drop me a message. Wire A also 0, B also 0. Wire A also sending 0, B also sending 0. What should my output? 0. Very good. Yes, my output is 0. Right. Then on wire B turns on. Wire A is or else switch of the motion sensor, whatever the thing connected to the wire, A sending 0, B is sending 1. Now what is my output? Now what is my output? Exactly, my output is still 0. Why? This is what gate lamai? This is what gate lamai? This is AND gate. This is AND gate. AND gate is supposed to multiply. AND gate is supposed to multiply, right? So what if A now sending 1, B is sending 0? Still my answer is 0. What if A and B both sends 1, and then only my output becomes what? 1. Then only my output becomes 1. Very good. Very good. Nice. Yes. Okay. Right. Start writing now. Now start writing. Draw this table. Draw this diagram. Put the topic gates. මේ විදිහට ලියාගෙන යන්න use space හොඳට ඉඩ තියාගෙන අඳින්න. Right? When you are drawing, use good amount of space. I'm going to draw several tables this side like this. One table for the AND gate, another table for the OR gate, another table for the XOR gate, another table for the NOT gate here. So now you know one table will be taking like this. Like this, 4 tables are drawing. I'm going to draw such 4 tables. So quickly start writing. Start writing. Mute yourself, dear. Right? Mark this one, input wires. These are input wires. All these are what? Input wires. And these are what wires? These are what wires? These are what wires? Output wires. These are what wires? Output wires. These are output wires. Mark it. Sir, NAND and NOR are universal. Yes, they are universal. Where did you learn NAND and NOR? O level? Or the school started teaching it? O level, right? Yes. Right. Write it down. And drop me a message once you're done. I will start drawing the O gate. Let me know once you're done. Neela, all clear? If you understand this, I have no doubt on the others because you didn't do ICT in your O levels. So if you are getting the idea, that means perfect. Right, very good. Getting the idea, right? Very good. Yeah. As I'm saying, usually my students are brighter than me, really. Right. Generation Alpha. Then. You guys are still Gen Z, right? My generation, Gen Zs, right? Yeah. Ask Ailey. Ask your doubt. Were you there in the beginning of the meeting? First of all, if you join in middle, probably you have a doubt. No. Okay, ask. It's okay. What's your doubt? Oh, sorry. Okay, what's your doubt? Done. Done. Right, very good. Why ICT is this much hard? ICT is the most thrilling subject, and that's why ICT giving you this much of Z score. ICT is not hard. The other students are doing really well, but sometimes some students may feel it hard, and yeah, I know it's hard, Tamai. I don't want to lie. This is a bit hard. This is not easy as the other subjects, and that's why you are getting more reward for the challenge that you are facing. So if you want to earn well, the people who are doing the easy things are, you know what I'm meaning, right? The people who are doing the easy things won't survive much. There's a more demand, and we need for the society the people who can handle the challenges and the hard things. So obviously ICT is hard, and we need warriors to handle this level. So be the man up, and not the man up, I mean, take the gut. So ICT is interesting. ICT is interesting. And yes, it's hard, and that hardness gives you some thrill, some interest. It's such a subject. Okay, let's move on. Kids, for the OR gate, tell me the outputs. For the OR gate, tell me the outputs. Let's name it the same way, A and B. Nah, let's use some other naming. No need to be always A and B. Let's use P and Q. Let's use P. I will mark this wire as P wire. This is Q wire. Sorry, P wire and Q wire. Now tell me, if my P input wire and Q input wire is 0, both are 0, quickly tell me, what is my output? P is also 0, Q is also 0. What is my output? What should be my output? Very good, very good. On the table, okay. Okay, P, if the P is 0, Q is 0, my output is 0. Right. Why? OR gate is doing what, Puda? Addition. OR gate is doing addition. So 0 plus 0, 0. If Q got 1, still this is 0. What is my output? And my output is now 1. If I got P1, Q0, still my output is 1. Why? Addition. See, it is addition. It is adding the signals. So these are off signals and on signals. Zeros and ones, these are off signals and on signals. If so, tell me, on plus on, my output is what? Not 1 plus 1, 2. 1 plus 1, 2. But these are what? I said you, these are signals. On plus on, coming on plus on, what is my output? On plus on plus on, not double on. If you have two switches for the one bulb, switch it's not doubling up the light, right? Light the light is not doubling up, so it's on plus on. So hope it's clear, right? Okay, then XOR gate, Anna kids. Now a little bit hard one. Not hard, easy. Remember it like this. For the XOR gate to produce one signal, or as a positive signal, it should have opposite input signals. It should have opposite input signals. Let me write it. Giving 1 for opposite input signals. Right. Turning on only for the opposite input signals. Then tell me, think it like Lamai. That Q in the seminar also I said, for a baby to produce a baby, you should have a male and a female, opposite genders. You don't make babies from the male or female things. You should have a male and female, that opposite and one other. Opposite gender should be there to produce an output. Likewise, this gate also producing an output from the monkey. I'm talking about biology, I'm talking about science, right? Don't panic up. I'm talking about science. To produce an output, we should have two opposite genders of input. Remember it like this. Now tell me, if I have A and B, now A and B, let's take M and N. This one is M wire, this one is N wire. If my m wire and n wire, my output column is this one. If my m wire, if I want, I can give a letter to this output column also. I'm not just giving. If you want, you can write it as that. If my m and n both are 0, now tell me what is my output, dear? If my both the letters are 0, what is my output? Drop your message. Both the letters are 0. 1 කියන්න බෑ නීලා. Both the letters are 0 නේ. Similar genders. Similar genders, now my output should be what? XOR gate is turning on to opposite genders or as opposite signals for opposite input signals. Now both the input wires are generating 0 signals. My output should be what? My output should be what? Yeah, very good. 0, 0, 0, 0, 0. Very good. So my output should be 0. Right? Now, when the M is off, N is turning on, my output should be now what? 1. Opposite genders turning on. And opposite signals turning on. Like that. If this is 1, this is 0, what should be my output? 1. Opposite turns on. And if it is 1, 1, like that. What should be my output now? What should be my output? 1 and 1. It's not addition. It's not addition. Don't get confused with this symbol. This is 0. This is just the symbol we are using. This is just the symbol. For the AND gate, this is not the symbol we are using. Instead of multiplication, we are using a symbol called dot. Dot symbol we are using this symbol. Dot symbol. Right? We are not using this multiplication symbol. Or we are using addition symbol. This is not changing. XOR, this is the symbol we are using. We have symbols for each and every operation. So make a symbol. Here, this is the symbol. This is not minus. This is not minus. This is the bar. I will explain. First of all, write these tables now. If you haven't completed these tables yet, quickly write down these tables. Complete the tables. Complete the tables. Right, done. All good. Done. Very good. Right. Others, make your note nice. Maintain your note nicely. Right, done. Very good. Nice, good. Others, drop your message. Done me. Okay, Lamai. What is this gate? What is the name? Not. If the gate name is not, I said you, this gate has a one specialty. What is that? Limited to only one input wire. That is my specialty in this. That is our specialty in this not gate. That is the specialty in this not gate. Limited to only one wire. We don't have multiple wires. Can it have, can it have more wires? No. So whatever the signal that you are giving, you assume your sensor is sending 0 signal, output will be 1. Opposite of it. If you are sending 1, your output will be 0. Opposite of it. If you are sending a male, your output will be a female. If you are sending a the opposite will come. Right? So, if I name this wire as like before, I also mentioned all the input wires with English letters like this. I can mention this wire also from an English letter, dear. Like, assume I will use letter C. I am using letter C. use A, B used. So I am using letter C here. Letter C. My output should be what, Lamai? C bar. That is how I am denoting this. That means if my input is C, my output is not C. My output is not C. Right? That means if my output is input is 0, output is 1. If my input is 1, output is 0. Hope this is clear. Right? So the truth table, if I'm making the truth table, very simple. We have only one wire. This is my output, C bar. We have only one wire. If this wire is 0, my output wire is 1. If my input wire is 1, my output wire is 0. Since I have only 2 wires, I have only 2 combinations. Because I am having only one wire, I have only two combinations. This is my table for NOT gate. Quickly write down. AND gate, OR gate, XOR gate, NOT gate. Quickly write down all the four gates. Make it quick. Waiting. Right. So explain once again, please. Okay, nice. So, Iman, the story was clear for you, right? So what I did was, for the OR gate, I just labeled the P and Q. So these are my P and Q wires, the possible signals that may come. These are the possible signals that may come. Either P can be 0, Q can be 0, both can be 0. Either P can be 0 and Q can turn to 1 from a motion sensor or the switch, whatever the thing. So these are the combinations. Yeah, wait 1 second. Ask me something again. Yes. Yeah, okay. Hurry. Okay, right? So like that, these are all the combinations. You see, since my OR gate acting as an addition, see, when my both the inputs are 0, output is 0. When my either one input is 1, it is becoming what? 1. Why? It is operating as a addition. It is operating as a addition. That is the reason, right? Okay. When you are coming to the XOR gate, it is acting as something else. Now this is acting as multiplication or AND gate. OR gate is acting as addition. XOR gate acting as, see, 1 for the opposite input signals. If my input wires are opposite to each other only, it is turning to 1. If not, the output is 0. See, if the M and N are 0 or 1 together similar now, see, these are similar, my output is 0. If my inputs are opposite, then my output is 1. That is what XOR is doing. XOR gate. What is NOT gate is doing? NOT gate is having only one input wire. When I turn that wire on, my output becomes off. When I turn that wire off, my output becomes on. It is acting as an inverter gate. So you can write that name also. Acting as what type of a gate? Inverter gate. Inverter gate for the NOT gate. Remember that word also. This is an inverter gate. Whatever the input signal coming, it is turning it to opposite of it. So those are the 4 operations of these gates. Is it clear, Imam? Is it clear for now? Drop me a message. Fine. Right. Shaped for now. The operations that this Iman, tell me exactly where did you ask me the right question, so it will be helpful to me to teach. Yeah, clear. Right. Clear. Very good. Right. Ask me the right question exactly where did you didn't understand, then I can exactly pinpoint and explain there the specific area. That will be helpful for me to teach. Right. So please, students, quickly not this one. Quickly write the note. Make it quick. And drop me a message once done. Drop me a message once done. 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 Nice. Okay. See, nicely maintain your note. And one more request. If your note is nice, drop a screenshot in the group. If your note is nice to look, balan nice nanda in the group. If you can proudly put it in the group, now we can join. Yeah, bad. Okay. It's very ugly. I told you to maintain it nicely. Right? When you're maintaining a note, make it look nice. Hurry. Okay. Shall we move? If you're done, drop me a message, kids, once you're done. Yeah, most of the students dropped me saying okay. Fine. Shall we move on? Shall I give you one small activity? And I want your screenshots. Screenshots, I mean, I want your photos. I want to see you. How did you understood? So we are moving to the next part. Converting a, no, let's have a small idea with universal gates also. Nah, universal gates. First of all, let's do a small activity and see whether did you understood this or not. Right. I am going to erase. If you didn't write the note, this will be helpful for today's session. So take a screenshot at least. Quickly take a screenshot. It's available now. Right. Okay. May hope you got it. I'm going to erase. Tell me, Lamai, AND gate is for multiplying, OR gate is for what? Adding, and XOR gate is for giving positive signal or else on signal for opposite inputs. Opposite inputs turning on. NOT gate is converting or else inverting the incoming signal. That is the job of these four main gates that you are learning, right? So I before told you in this lesson you are going to learn a logic gate conversion to Boolean expression. Boolean expression, right? Right. Let's write the Boolean expressions now. Let's practice this one. I'm erasing. Okay. Now, kids, I'm going to draw a small logic gate. Okay, this is an AND gate. This is wire A, this is wire B. Okay. This is a small OR gate. I am taking the wire B from here and I am taking wire C from here. Small OR gate, right? And I am connecting all these from another small OR gate. Now, look carefully how I am going to write the output. First of all, explaining, then after that you can start doing. This is for explaining purposes. Now, this is the gate. This is how you are getting the diagrams. This is a logic gate diagram. This is a logic gate diagram. Now, tell me, what is this gate? Nihila and Iman and Aili, what is this gate? What is this gate? Drop your message. AND gate. AND gate. This is AND gate. You should remember the shape. Remember the shape. This is AND gate. If that is AND gate, what is the operation? What is the operation? Addition, multiplying. What? What is the operation? Being very slow. Okay. Multiplication. It is multiplying. So you are getting A from here. You are getting A from here. You are getting B from here. You have to multiply these two. If you write multiplication wrong, right? You should write dot. I said you should write the symbol. Symbol is lamai dot, or else don't write anything, because if you are not writing anything, that means what? Multiplication is there. That means lamai xy means x multiplied by y. That rule, remember, in mathematics, xy means x multiplied by y. So you can write either AB or else A dot B, right? Whatever the output that you are getting from a logic gate, please bracket it. Bracket it down like this. Understood? Right? That is the step. Now tell me, what is the input signal you are getting from this way? The B, right? You are getting B from here. Here, what are you getting? Here, what are you getting? C. B, C. What is this gate? What is this gate? B, C. What is this gate? Very good. OR gate. OR gate means what is the operation? OR gate means what is the operation? What is the operation? Plus, plus, plus. That means lamai B plus C. Bracket. Every output from every gate you have to bracket. Every output from every gate you have to bracket. Now A dot B from here, B plus C from here. This is what you are getting, not just only letters. Now you are getting expressions for this gate. Now tell me, what is the operation here? What is this gate? What is the operation? What is the gate? What is the operation? Quickly, like before you said, here multiplication, dot. Here addition, plus. Here what is the gate? O gate. O gate means what is the operation? Plus. O gate means plus. Okay. What are you adding? What are you getting from this side? You are getting A dot B. A dot B. You are getting A dot B this side. What are you getting from this side? B plus C. B plus C. Okay. At both. Here, this is your operation. You are getting A dot B from this side, you wrote. You got B plus C from this side, you wrote. And what is the operation you are supposed to do from this gate? Addition. You wrote it in the middle. Now, this is your what, Lamai? What is this? What is this? This is Boolean expression. You found the Boolean expression. Is this hard? Huh? ICT is hard? Who said? Right. Understood. Very good. Nice. Right. Crystal. Okay. Very good. Nice. This clear. Okay. Very good. Right. Okay. Very good idea. Right. All good. All good. All good. All the answers are very good. Clear. Right. Now I'm going to give another one. Now, my number. Note down. If you don't have my personal number, my number is 072494335 This is my personal number. Now I am going to give you a small activity to find the Boolean expression from the gate that I am going to draw here. You should find the Boolean expression and send me. I need with the steps. Therefore, take a photo and upload in the group. Right? In the group, don't send me private, Ani. It's hard for me to check. I'm checking who's the first. So in the group, it will be easy for me to check who's sending it, who's doing the work faster. So let's see. Place your image at top. Hurry. I'm erasing. Take your pens ready. Hope everything clear. Right? I'm erasing. Right. My kids, is that bad that I am not using Sinhala or Tamil or the other languages? Not me. Is it good? This is good when I'm using only on English. It will be easy for everyone. Right. Okay. Make it quick. Still not hard ones. Still these are very simple ones. A, B, C, D. First one. Quickly do. Quickly find. I'm waiting. Quickly find. Drop that one and find this one. Let me name this as F. So the question is find F. Sorry. Waiting for your answers. Let's see. Aili, wrong group. Anyway, yeah. Aili's answer is correct. Correct. Bracket. Where's the bracket? Aili, where's the bracket? You have to put the bracket. Right. Altaf. Okay, fine. Good. Altaf's answers are correct. I'm waiting for the others. Quickly draw. You need to draw the gate. You need to draw the gate. Sir, should we only send the answer with the diagram also? With the diagram. Draw the diagram. Get your hands used to draw the diagrams. Yeah. Altaf first. Waiting for the others. Quickly. Put your diagrams in the group. Sir, I can't see. Wait. You can see now. Right. Waiting for your diagrams. Sir, I didn't know the group. Group was highly Prime ICT online. Let me send you the group first straight. Well done, Hakim. Right. Addison Rock. Who is that? Zuha, correct. Correct. Addison, correct. Abdul Hakim's correct. Correct, correct, correct. Where are the others? Nihila, what about you? Very good. Who is this 905? 905 is this Chanuli. Okay, Chanuli Tama. Yeah, right, very good. Where are the others? There are around 15 students here. Ne? So 14 students are here. Only 3 or 4 doing the work. You don't be like that. Huh? Engage in the activities and get through these. Right, let me explain that. Yeah, no point of waiting. I'll explain. Time is going. Right, kids. Here we have what gate and gate. And gate means, let me quickly write down my operations. And gate means what la my symbol is dot. Dot means what la my multiplication. Multiplication. Okay, fine. Or gate means la my plus. Plus means it in addition. Plus means addition. Not gate is la my what? Bar. Bar. Bar means inversion, opposite. Inversion, or else doing the opposite, right? Okay. A dot B. Ne, and gate ne, this is what gate, and gate ne. And gate output is A dot B, bracket. All the outputs bracket it. Right. So here again and gate ne, what? C dot D, bracket. What is this gate? O gate. So what should you do? Addition. A dot B plus C dot D, addition. What you got from here, A, B, what you got from here, C, D, C dot D, right? Onan dot dagan with or without dots. You can write multiplication with or without dots. Okay, here, this one. What is this gate? Not gate. What are you supposed to write? Bar. Write a bar on top of A. This is not gate. Right. From here, what are you getting? B. So what is this gate? AND gate. Write A bar, which you are getting from this side. Write B, which you are getting from this side. What is my operation? Dot. My y AND gate is doing the multiplication. What is my symbol? Dot. I am writing that symbol in between the numbers that I am getting as inputs. Now, bracket. If you forget the bracket, you are in danger, right? What are you getting from here? C. Very simple. You are getting C from there. Here you are getting A, B dot bracket. Here you are getting C. What is the gate? To write the operation, you should always remember that what is this gate? O gate. O gate means what's the operation? Plus this input. What is the input? C. All clear. Those are my final outputs. Yes. Okay, very good. Nihila, all clear up to this? Is everything clear? All clear? Shall I give you some complex ones to solve? Shall I give a complex one to solve? Yeah. Okay, right. So I'm erasing this one. Zuha Zuha laging these things are like bubble gum for Zuha. Altaf and all less වහගෙන අහක බලාගෙන කරනවා නේ Altaf will do from this one from the left hand while making a kottu roti from right hand Such a person, Altaf. Right. Right. What are you saying? Okay. Now, if you can handle this one. A, B, C, right? D, uh, on. This is my gate. Find the answer. Find the answer if you can. And drop me the message. Find the answer if you can and drop me a message. I'm waiting. Try it quickly. Iman, do. Iman, everything clear, right, Iman? Abdul, everything clear? Yeah. Can't see. Yeah, all clear. Right. Very good. Mm. I'm getting the answers. Very good. Zaid sending me personal. Okay. Okay. Right. Who's first? Okay. Amar. Nah. Aili. Aili, very good. Correct. Aili first. Abdul Hakim second. Right. What has happened to Altaf? Did he really try to make a kotturuti? What happened? Yeah. Anyway, the answer is correct, but it's like a kotturuti anyway. Zuha's correct. Easy things for Zuha. Dihila correct. Okay. 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 Right. What are you saying? Okay. Let's try the next one. Right. Okay. XOR gate. Okay. Uh, Not gate. Okay. Or gate. Okay. Then shall we move on a little bit further and let's identify. Let's understand what are the other gates also. NAND gate and NOR gate. NAND gate and NOR gate. Yeah. So may write the topic. I don't want to waste much time on this. Now you guys already know the one stage is already done. From a logic gate, now you know to write the Boolean expression easily. It's easy, right? So to do that correctly, you need these two gates understanding also. Write the topic universal gates. Universal gates, right? And the two universal gates that you need to deal with is NAND gate, NAND gate, and NOR gate. Very simple. NAND gate and NOR gate. So guys, in the NAND gate, what do you have? The gate is like this. Two wires, two or whatever the number of wires you may have as input wires. You have a circle here, dear, and this is your output wire. NOR gate, okay, something like a no gate, but you have a circle in front of it. So may the wires in behind are what wires as usual. These are what wires. All these are what wires. input wires. All these are what wires? Input wires. These are what wires? As usual, output wires. These are output wires. Hari. So, what is the operation? What is the operation? No different operation. This is an AND gate. This is a NOT gate. So that means this is very similar to a AND gate having a NOT gate in front. This is a very similar thing which is having OR gate and a NOT gate in front. Another thing I want to teach you. See here. Now, if you are having a NOT gate like this, pointing to a AND gate like this. This is A, this is B now. Now you should have the understanding that this is A bar. This A becomes A bar once it's passing the NOT gate. And here you are getting B without any issue. After that, here you are getting A dot B, A bar dot B. This is your output. What if you send it this way? See the difference here. See the difference here. You are sending A here. You are sending. Wait. You are sending A here. You are sending B here. Right? What if you have the AND gate here and you have the NOT gate here? What's happening really? Tell me. A is coming nicely. A is coming nicely. B is also coming nicely. No issue. In here in middle, what's happening? In here in middle, what's happening? This is what gate? AND gate. So what is the operation? What are you getting from here? You are getting A. What are you getting from here? You are getting B. What is the operation? Dot bracket. Now this one, this entire packet is going through what gate, dear? NOT gate. So my final answer after this NOT gate will be, this NOT gate will be whatever the rubbish that is going through this NOT gate having a toppy bar. Like this. Full bar. Earlier we had only one bar to the A. When having one bar to the A, we got A bar and we can do the processes as we did before. And here what's happening? Here I am having the NOT gate after the AND gate. And that's making me to do this. A dot B first, doing the AND gate operation. After that, it is the entire packet is going from the NOT gate. Then it is going through the NOT gate. We should put the bar to entire whatever the getting as input. From the input we are getting entire packet. Put the bar to the entire packet. NOT gate. Now tell me from the logic. Tell me, මෙතනත් NOT gate එකක් තිබ්බොත්. What if you have a NOT gate here? What if you have a NOT gate here? What probably should be my output here? What is my output here? Tell me. What is my F? What is my output here? Any brilliant students? Any brilliant students? Altaf, what are you doing? Don't read out loud, please, and don't read my name either. Okay. 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 Right. I'll check on this. I didn't see, not is it. Right? So, Abdul Hakim, your XOR gate is wrong. Right? XOR symbol, Abdul Hakim. This is the XOR symbol. Or the plus circle. You haven't put the circle, I guess. Check. You haven't put the circle. Right. Okay. Yeah, my mistake. Okay, fine. Alright. Now tell me. You don't try to find who found the mistake. No. Okay. Okay, fine. Hurry. See, will you? What is the answer for this one? Tell me. Tell me. What's the answer for this one? Now I am having the NOT gate different wires. I am having A bar here. I am having B bar here. I am having B bar here separately, kids. See, I am having B bar here separately. Now see, if I am having A bar here and B bar here, what is this gate? AND gate. Whatever the thing you are getting from this side, you should write it here. Where? Here, like this. A bar. Whatever the thing you are getting from this side, you are getting B bar. You are getting B bar separately. Okay. You are writing B bar. What is the individual operation? Dot, bracket the output. Bracket the output. Dear, can you understand the difference here? If I place the NOT gates behind the NAND gate, I am getting two separate bars for two separate numbers. Obviously, yes, I am passing A here, so I am getting A bar. I am passing B here, so I am getting B bar. Separate numbers, so I am finally multiplying those two numbers. That is the operation here. But here, I am placing the NOT gate here. NOT gate out of the AND gate. Out of the AND gate. Therefore, when I pass the A from this side, B from this side, first of all, it is doing the multiplication, and after that, for this NOT gate, it is getting this entire packet. I am putting the bar total. Is this clear? If this one is clear, this is nothing. If this concept is clear, this is fully clear. Drop me a message. Whatever I told here, is it clear? Drop me. Yeah. Yes. What about Neela? What about Tamar? What about others? Zuha clear? Yeah. Iman, crystal clear. What about Neela? Yeah. Zain, clear. Very good. Neela, clear. Obviously, yes, ne, true, ne. Usually, Neela is asking if it is not clear. Okay, fine. Then, Lamai, what is happening in the NAND gate? NAND gate means combination of AND gate and this NOT gate. Sorry. And NAND gate means AND gate. In front of there, we have a NOT gate. That means if I am passing A and B, assume A and B pass karna, whatever the letter, what is the first output you are getting from the AND gate? A dot B. Ni. What is the next output when it is passing from the NOT gate you are getting? A dot B bar. Ni. This is your output. This is your output you are getting from the NAND gate. Hope it's clear. Hope it is clear. Right? Clear. Very good. So, NOR and XOR, it's acting same or something, not acting same, it's different. I will explain, right? Wait. So, let's do the same operation for the NOR gate. You are having a O gate, in front of there you are having a NOT gate. Ne? That's what having me. So, here, if you are passing A and B same as before, from this O gate, you know what is the operation plus. So, you do the A plus B bracket, right? You do the A plus B. After that, here dot means, Lamai, what gate? NOT gate. This circle means you are having a NOT gate. NOT gate means you are placing entire bar on top of it. Ne? A plus B full bar. A plus B full bar. Up to here, if everything clear, you are very good and safe to move forward. Right? Drop me a message, kids. Drop me a message. Is all this clear? If it is clear. Yeah. Full clear, ne? Right. Okay. Then, kids, let's write the truth tables also quickly without wasting our time. Let's quickly write the truth table for the NAND gate and NOR gate also. Right? Yeah. Now, assume you have, I took A, B, A, B. Sorry. My output, I will say out. Sorry. Output of this one. First of all, I will write the output of A dot B. Sorry. After that, I may have another column for the final output. Right? So, A dot B bar. A dot B bar. This is my final output. Right? Here I am having A dot B. Here I am having A dot B bar. Let me erase this one and I will write the exact expression here. It will be easy for you to understand. Yeah, this is A dot B. This is A dot B bar. Okay. Now you know what is the operation coming from the A dot B. A dot B means acting like what? Multiplication. So multiply 0, 0, answer is 0. 0 into 1, answer is 0. 1 into 0, answer is 0. 1 into 1 only you are getting 1. So when you are having a NOT gate, what is the operation? Whatever it's getting as input, the output will be its opposite. None. If the output is opposite of the input, this is the input for the NOT gate. So my output should be 1, 1, 1, 0. Agreeing with me? Correct, right? This is my final output of the NAND gate, right? This is my final output of the NAND gate, right? Okay. Clear? Is this clear? Is this gate clear? Is this truth table clear? If not, shall I explain it step by step, or is it clear? Drop your message, kids. If it is not clear for anyone, drop your message. Yeah, clear. Very good. Very good. What about the others? Neela, clear how it worked? A, when it is A0, B0, A dot B means multiplication, so 0. When it is A0, B1, still it is multiplication, 0, 0, 0. Not gate means the opposite of this name, whatever the getting from here, it's opposite. So I placed 1, 1, 1, 0. Opposite of this column here. Understood the, is it clear? So again, having connection issues. Once more. Okay. Let's do it step by step. One more time. Wait. If not, if you confuse it this time, it will be hard for you to proceed. Okay. Therefore, I will be doing step by step. Okay. Assume here, the sensor that is connected to A, then the switch that is connected to B. Assume that story. Okay. Both are giving me 0 signal. Since I am having AND gate here, first of all, this is NAND gate, but NAND gate means having actually 2 gates, AND and NOT. So let's consider about the AND gate first. AND gate means multiplication, Zain, Nihila. So if you multiply these two, you are getting what? 0. But since you are having NOT gate, opposite of it, 1 is your real output. Understood the Zain? Understood everyone? Hope it is clear, right? Right. Then again, if the switch is off and the motion sensor is on, still 1 into 0, answer is 0. Our AND gate output is 0, but I have NOT gate also. Therefore, my output is what? 1. Opposite of this. Opposite of my output is my real output now. The AND gate's output's opposite is my real output here. Understood the saying? So if I'm having 1, 0, still AND gate, you know, we did AND gate multiplication. So 1 into 0 is 0. Since I have a NOT gate, whatever the output that I'm getting here, it's opposite 1. Right? So when I have both 1 and a 1 into 1, AND gate act as multiplication. So 1 into 1, 1. Opposite of 1 is 0. So my final output is 0. Understood the Zain and Nihil and Iman and everyone? Is it fully clear now? Drop me a message. Yes. Yes. Sir, your connection is not so good, mate. My connection is bad. Shall I show you what is my connection? You see, SLT fiber 2.4G. Yeah. It's your end connection, not my connection. I have paid a lot and purchased this SLT fiber, which is the fastest internet option available in Sri Lanka. Even the Starlink is slower than SLT fiber internet connection. This is the fastest. Fiber optics is the fastest, right? So probably no, not my side connection issue. It's your side connection issue. Hurry. Right. Shall I move then? Is it clear? Note down this, dear. Note down this under AND gate. You should draw this one under the AND gate. not under the both the gates together. I may move it aside a bit here. If this was a smart board, I can nicely select this and move it. But for the time being, sadly, I don't have the smart board in my access now. Right? So draw it and drop me a message. I'm waiting for your message. Quickly draw it. Draw it, dear. And drop me a message. Done. Wait. Hurry. What about the others? Zuha, Chanuli, and all? Done. Done. Iman, done. What about the others? Waiting for the messages. Another 1 or 2 message. I'm okay. I will proceed. Chanuli, what about the others? Zain, what about the others? Quickly write it down. Okay, Zain done. Tashishi done. Very good. Chanuli. Aili, Zuha, Abdul Hakim. Once you wrote this one, quickly tell me. Maintain your notes nicely. Draw this truth table under the NAND gate. Huh? Right, done. Very good. Right, done. So I'm moving. Right, done. Very good. Right. So if you are late, take a screenshot. I'm moving. Okay. Then right. So I will draw the truth table for the NOR gate also. NOR gate also. So what are my input wires? A and B. My input wires are what? A and B are my input wires, right? A can be 0, B can be 0. A can be 0, B can be 0. A can be 0, B can be 1. A can be 0, B can be 1. Yeah, A can be 1 at a time, B can be 0. Yeah, okay. Both can be 1 at a time. Those are the possibilities. So the first output from my first gate should be A plus B, kids. A plus B, first output. O gate, O gate is having A plus B. After that column, you are having what? A plus B bar. Now help me quickly. Plus 0 plus 0, 0. 0 plus 1, 1. 1 plus 0, 1. 1 plus 1, 1. Turn your page and see your O gate truth table. Your O gate truth table. Same thing again. So when you have two possibilities, A plus B means it's adding. It's O gate is acting as an addition. O gate is acting as an addition. But the problem is now we have a NOT gate in front. We have a NOT gate in front. That means whatever the answer you got just now, just the opposite of it. Write the opposite of it. If you got 0, that means your final answer is 1. If you got 1, your final answer is zeros. Your final answer is 0. Now tell me, this is the final output of NOR gate. Who asked me, is the NOR gate and XOR gate is similar? See the outputs. You have the truth table of the XOR gate, how the XOR gate is behaving. You have now the truth table of the NOR gate. You know how the NOR gate is behaving. XOR gate is behaving. XOR gate is turning the output to number 1 when the inputs are opposite. When the two inputs are opposite. Now the XOR is having only 2 inputs usually. XOR is having 2 inputs usually. When the inputs are opposite to each other, my output is what? Positive. If the inputs are similar, that means 1 and 1, 0 and 0, similar inputs. Now my output should be 0. That's XOR gate. What is happening here? It is opposite of OR gate. So when you are adding, you are getting one, it is just the opposite number. You cannot give an idea or another interpretation. You have to draw and see how it is behaving. If not, you can't find it. Are understood the kids? All clear? Draw this if it is clear. If you have doubts, you can ask me. If it is clear, drop me a message. Yes, clear. Very good. Clear. Okay. Write it down. Write the truth table of the NOR gate and drop me a message. I'm waiting. Done, Nihila. Very good. Right, done. Tashishi. Very good. Done, Chanli. Very good. Right. Okay. Okay, kids. I'm going to erase then. Others quickly write down. I'm giving you 2 minutes. Make it quick and inform. I'm going to erase and I'm moving forward. Right. The last thing for today, I need to allow you to draw a diagram also from a given expression. And before that, I want to give a good sum before moving to that part. So today we understood how to convert a diagram to the expression. Now we know how to write the expression from a diagram, right? Hope everything clear. And hope it's doesn't mind this video will be published in YouTube for everyone. And the lessons from this following this will be for the paid users. And if you are a physical class student, you will be having the access continuously through the eduzone.college.lk website. Unless you are online paid class student, you won't get the access, because if not, it will be an unfair decision for these students who are paying and coming. And I like to give away these things free. This is knowledge. I don't have any authority on knowledge, but you know, for this setup, the internet, the people who are working behind, and everything costs. Eduzonecollege.lk website costs, hosting costs, everything is having a cost. So I have to cover all. Me. And me A level A level class for 2000 rupees, no one is doing me for a month. Even though O level class is costing more than that, Me. So I'm doing it for the lowest cost. You're saving the transportation cost also when the class is online. You're having multiple advantages. Wow. During my time period when I was learning, I didn't have such facilities. You're having the LMSs, Zoom facilities, internet, and you're learning online, staying in with home clothes at home. What experience, eh? Right. Hope everything done. And this makes you lazy even more. So when I ask recording near sirs, they ask email address. Why is that? They are making their videos private. Now I am making unlisted and I am publishing in my website. So my YouTube videos are unlisted. So if you have the link, you can share it and watch it. But you cannot find the link from my website. I have blocked it. So the other teachers relying on YouTube security. So they private their videos and asking your email address and sending your giving your access to your email address only. So even though you have the link, you can't share it with others. That is the way. So if you want to share it with others, you have to, let me tell you the trick. You have to make a common Google account and give that email to the teacher. Then when the teacher is giving that access to that Gmail account, you can share your Gmail account's password, username and password with your friends, and you can watch the recording that way. On the things that we are used to do when we are doing A levels. We didn't continue it because we knew that our teachers also needed the money and the charges to maintain all these. These facilities will be going and ending near soon because they can't continue the classroom if you do that way, right? And ICT, I haven't went for any teacher in my A levels. No one can claim Anni Duralakidu is my student. No one can claim. I learned my own. Okay. Erasing. For The other two subjects I went under Hilmi sir. ICT, I did my own. Already I knew what I will learn in A levels. So, okay. Download that YouTube video. Oh, okay. Okay, next. Another challenge question. Are you okay? After that, we will do a small Kahoot also. Shall we do this challenge question and do us one small Kahoot and we'll wind up the session? We will continue the rest of the things in the upcoming sessions. Is that okay? Okay. Then do this one. A. Now this is a joint. I'm taking the value from here. I have to circle it, right? Find the answer. Find the F. This is the challenge. And drop the messages to the WhatsApp group. Drop the messages to the WhatsApp group. Right. Waiting for your responses. You cannot find my unlisted videos neither from the website. You can't find them because it's asking the full screen mode, so you can right click or do anything. Screen record puluwanda. I'm not sure about that. I guess you can't do the screen recording also. And in future, in near future, I will be developing an app, so the screen recording also won't be possible anymore. It will be full black in blank. Blank in blank. For your own goodwill to continue all these setup, we need a small amount of money to continue this. That's why your charge is so low. As I said, my target is not a big crowd. My target is quality students. Yeah, I got an A to IT without even going classes. Because I didn't, that ICT was my life-saving option, because even from the O levels, I knew my A level syllabus. So I had only 2 subjects in A levels. ICT is a free hit to me. If it is something else, I won't score this much, because 3 subjects is a headache to me. I can't handle 3 subjects. In my A levels, I just handled only 2 subjects really. Okay. Okay. Sorry. I want to check the group, waiting for your responses. Okay, I'll come back to you, Altaf. Let's First of all, let's check the answers. Tashishi is sending in private sending. Don't send me in private. You are sending because you are not sure about the answer. That's why. But Tashishi, your diagram is very neat. Huh? I like the way you draw the diagrams. Very neat. Really nice to see. That come mature neat. Nice. 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 Correct. Why you are sending private? Your diagrams are neat. Send into the group. Zuha was the first. Okay. Wait. Tashishi, yeah, there's a small mistake in you. Tashishi, there's a small mistake. The NAND gate. NAND gate should have a final top bar and your diagram is not having it. One small mistake, I think, because of the carelessness. Yes. Who is this? Addison Rocks I don't know. Anyway, his answer is correct. Very good. Altaf's answer is Altaf's answer. Altaf, you have to circle the plus, not the multiplication sign. You have drawn a multiplication sign and you have circled it. Something off there. And Nihila's answer is again wrong. Nihila, what has happened? Nihila? Chanuli's answer is correct. Amar again having a mistake. Amar, what has happened? This is an AND gate. Amar, your diagram is wrong. This is an AND gate. Abdul Hakim's answer is correct, but Abdul Hakim, follow my instructions. I have given you the instruction to draw a bracket from every output. If you don't follow that rule, you will end up making wrong outputs very often. Yeah, now correct. Now correct, Tashishi. Your answer is correct now. Right. Abdul Hakim, please go with the brackets. Others, all the other answers are correct. Nihila, one small mistake. Amar, one small mistake. Let's see the answers. Right. Okay, kids. Help me to go through with this. A means what? Out of when the A is coming from the A dot gate, you're having a bar. This is not gate. Once you coming through this gate, you are getting a bar. So P on top of it. Right. Here you are having B. Right. So this is what gate? AND gate. This is a NAND gate. You can see the dot here. Without this dot, it is AND gate. With this dot, it is NAND gate. NAND gate means one with a NOT gate in front. So what are you getting here? Here you are getting A bar. Here you are getting B. NAND gate means dot. NOT gate means fully bar. NOT gate means fully, you have to apply a bar. Here you are getting A. Here you are getting A here. Right. You are getting C nicely from here. Right. A, C, both gone through what this gate? What is this gate? We are calling this as XOR gate. You are calling this as XOR gate. Then XOR, what is the operation? Plus circle. Plus circle. That means opposite inputs, positive output. Opposite inputs, positive output. What are the numbers you are getting? What are the letters? Here you are getting A. Here you are getting C. Right bracket. Fine. Now what are you getting for this gate? Here you are getting A bar dot B full bar. Here you are getting A XOR B. So pass both the inputs inside this F. Here you are getting A bar dot B full bar. Here you are getting A XOR C. Finally, here you have this NOT gate. This is what gate, dear? This is a NOT gate. So put a NOT gate on front with an operation like a plus. Why? This is O gate. But this gate, this is a O gate. So my operation is plus. Since I am having a NOT gate, I will put a full bar on top of my full equation. Is it clear? Nihila understood your mistake. Understood your mistake. Is it fully clear? Shall we do the last Kahoot for today and finish it off? Is this clear? So today we learned, drop me a message first, students. Is all the things that you learned today is clear? Yes, understood. Very good. So that was your O-level stuff. All I did today was just O-level stuff. Sir, A dot B, why 3 bars? A dot B, why 3 bars? Oh, okay, Zaid. See here, will you? The A is coming from this NOT gate first. So only A getting 1 bar. See, A getting a 1 bar individually. That is only for A because A is coming this NOT gate alone. This say, sorry. The A is going along through the bar. So A is getting a 1 hat. After that, here see, this is also another gate, another NOT gate. But this time A is not going alone. The 1 bar is there for A, and here the V is coming. With B, he is going under this NOT gate also. So here A bar dot B having a full bar. After that, here see again he is going through another NOT gate. 3 NOT gates. A is passing 3 NOT gates. See, A is passing 3 NOT gates. So A should have 3 bars on top of it. Here, when he is going here, A bar B together has a full bar, and then again going through this NOT gate, this NOR gate. See, A bar dot B bar is coming from this side, A XOR B is coming from this side. What is the operation here? Plus. And what is the operation here? NOT gate having a full bar. Zain understood the Zain? Is it clear? Drop me a message. Understood. Okay. What about the others? All clear, right? Very good. Right, kids. Then, are you ready for a Kahoot? Those who don't know about Kahoot, drop me a message. If you have a browser, obviously you should have, you're coming to this online class from a device. If you are having a browser, come to kahoot.it. I'm going to host a Kahoot exam, a small one, 5 questions. Are you ready? A small one. And don't ask for cash prices. Cash prices, my entire, yeah. Abdul Hakim, my doubt. Sir, no and XOR is acting same or different? It's different. Is that your doubt, Abdul Hakim? That is your doubt there. Is that your doubt, Abdul Hakim? NOR gate and XOR gate? Or else are you having another doubt? Drop me a message. Others, no doubts, right? If you have doubts on the today's lesson, please clarify it today itself. You can't move forward without a clear understanding on today's work. Should have 100% crystal clear understanding in order to move forward. Abdul Hakim, what is your doubt, dear? My bad. Please tell me your doubt again, please. So, function differences. Okay, wait. Wait. I'll show you this way. Then, Balanda, if you are having an XOR, assume you have A and B. Assume both are 1, both are zeros. Your output should be what? Similar is a 0. XOR, when it is inputs are similar, it's 0. Okay. So when you are having opposite outputs like inputs like this, you are having 1. When you are having again similar outputs, you are having zeros. That is the function of XOR gate, right? So when you are having the NOR gate means this gate. This is NOR gate. O gate with an NOT gate. Okay. If you have A and B, what is your output? A0, B0. Your output should be outputs deka clear ganna, because since I am having 2 gates, I can't directly write the output like that. I should write output 1. What is my first output? A plus B. And my output 2 is A plus B bar, a bar on top of it. These are my output. This is my final output. This is my correct final output. This one I took just to find the output of the OR gate only. Right, Abdul Hakim? So now, when you are having two zeros, A plus B means 0 plus B, 0 plus 0, 0. But you have a NOT gate, opposite of it is 1. Understood, Abdul Hakim? Up to here, clear? The process is clear. Drop me a message. Is this process is clear? What I am doing is clear? First of all, is it clear what I am doing is clear? When you are having two zeros, when you're having two, one zero and one, 0 and 1, since these are addition, OR gate means addition, 0 plus 1, 1, opposite of it, 0. Right? After that, this one, this is 0, this is 1, this is 0. So 0 plus 1, 1, opposite of it, 0. Right? And then 1, 1, 1 plus 1 is 1, opposite of it is 0. So, Abdul Hakim, see, same inputs I gave. I gave the same inputs for the two gates. See, these are the possible inputs for the what gate? XOR gate. These are the possible inputs to the NOR gate. Both are similar. Is 0, 0, 0, 1, 1, 0, 1, 1. Right? So, XOR gave me this output. NOR gate gave me this output. Can you see the difference here? So it's not same, it's different. Abdul Hakim, is it clear? Drop me a message. Yeah, now clear, fine. Sir, is the Kahoot today's lesson? Yeah, from today's lesson. Clear, fine, right, okay. Then let's go to a Kahoot, kahoot.com. Yes, come to kahoot.it. Sir, my data not working properly. I think I can't do. Why Nihila Aparadi? Right, 1 second. Logic gates. It's easy. Just be faster. 5 questions first of all for beginner level. All you learned today stuff was just O level stuff. Huh? All these things are O level stuff. Okay, kids, quickly join to this session, to this quiz, which is an MCQ quiz. Let me share you the link. Click the link and come to the game. Click this link and come to the game. One link is available in the chat. Yeah. Link is available in the Zoom chat. Click it and quickly you will be in the game. Zain, okay. Ashwin, where about the others? Altaf has come. Addison. So wait, I'll try to join. Okay, sure. Tashishi. Shanuli, where's you? Right. Abdul Hakim, Shanuli came. Abdul Hakim, where are you? Co-host, can you put this Kahoot link to the group as well? WhatsApp group. Still 6 participants. Where is our champions? Co-op champions la. And Altaf is here. Zuha Oni. Nuhan is here. Okay. Right. Amar is here. Zuha is here. Nihila, shall I wait for you? Is it possible for you to come? Yeah. struggling with the connection there. Yeah, no, you can. Yeah. Have you went to watch Spider-Man brand new day? Watching? You guys are watching Marvels, right? Till lama, you guys are 2028 commerce. You're having the make hale karot tama from next year onwards. Don't go to watch movies. Please be focused and study. This period, okay, you can watch a movie once a month. Again, in the buluwa shape, okay, you can do the work plus that also. But after 1 year, when you're in 2027, next year again, stop all your other things and stay focused. Okay, 11 here. Shall I start? Should I wait for anyone? Drop me a message quickly. Should I wait for anyone? Drop me a message. If not, I'm going to start. 3, 2, no messages. So I'm starting. 3, 2, 1. This is gonna be super easy, kids. Try. Okay, started. What is the output of a NOT gate if the input is 1? Very simple. Output of a NOT gate if the input is 1. What is the output? Okay, 0. And who says 1? We 2 people saying 1. NOT gate is an inverter gate. Inverter gate means whatever the input you are getting, it is opposite only you are getting as output. Right? Altaf first, Zuha second, Abdul third, Chanuli fourth, Amar fifth. Okay, let's see. Second question. Which logic gate outputs 1 only if both inputs are 1? Which logic gate outputs 1 only if both the inputs are 1? Be smart. Very good. AND gate act as multiplication. For then only it getting 1. Both the inputs should be 1 to get a 1 in multiplication. So very good. 10 answers are correct. 1 wrong answer. Kaude. I will see from the report. Zuha, first place. Okay. Abdul Hakim, second place. Altaf, what happened? A little bit slow. Third place. Chanuli has climbed up to the third place. Altaf, fourth place. Nuhan, fifth place. Very good. Right. Which mathematical symbol represents O operation? What is the mathematical symbol for the O gate? Plus. Very good. Ayyane circle plus daanne. Circle plus to me. Minus. O gate minus. Who says minus? Someone is playing for fun there. What has happened? Chanuli second place. Neha climbed up to the leaderboard. Very good, Neela. Right. Fourth one. If input A is 0, input B is 0. If the gate is O gate, what is your output? Both are 0. Gate is O gate. What is your output? Be quick. Very good. 10 correct answers, 1 wrong answer. Lamai. A0, B0. O gate plus nang. 0 plus 0, 0. 0 is the answer. Right. Very good. No change. Another hard game. Next, last question. How is A and B written in Boolean expression? A and B. Yeah, atana podi podak mekak kela dina. AB has typed 2 times, but anyway, A dot B is the correct answer. Still, you can answer. Only 6. Lamai. How is A and B? And B means multiplication. Multiplication means what is our symbol? Algebraic expression symbol is dot. Dot is our symbol. Even Nihila did it, right? Dot is our symbol. This is O gate. Plus means O gate. Minus kila bit. We haven't had any minus. So okay, fine. Right. According to that, third place goes to Altaf. Very good. Second place goes to Abdul Hakim. Never expected. Okay, because that was a very tough game. You were behind. Okay, Zuha, first place, as usual. Eduzone fourth, Chanuli fifth. What happened to Neela? Sharp game. Really sharp game. Very good. Very good. Very good. Okay, kids. Okay. Before winding up, shall we do another one more? Do you have the gut to do another one more? Quickly, 5 questions. Can? Yeah. Sure. I'll send the link. Yes, sir. One more. Okay, fine. Come to the screen. Right. Here we go. Here's the link. Waiting for you. Let's finish it off quickly. Come soon. Come soon. Ihila came, Ashwin came, Altaf came, Amar came, Tashishi came, Eduzone came. Who else remaining? Zuha remaining. Abdul Hakim came, Chanuli came, Nohan came. Where's Zuha? Ten people are here. Zuha is late. Zuha late. What happened to Zuha? We are waiting for Zuha. Right? Connecting. Okay. We are having the software engineering session after this. Yeah. Okay. Zuha came and went. Okay. Came, ne? Okay, we are starting quiz 2. Logic gates quiz 2. Right. Which gate is also known as inverter gate? What is the inverter gate? Not gate. Annelamai. N gate and N gate. Those are not inverter gates. What has happened to you all? Not gate is the inverter gate. The gate that is inverting or else converting the number to its opposite number. Okay, anyway. Right. Abdul Hakim first, Zain second, Chanuli third, Altaf fourth, Amar fifth. Zuha is not even in the leaderboard. What has happened to Zuha? Connection problem, I guess. Solve this logic problem. A and 1. 1 and 0. Excuse me, sorry. 1 and 0. AND gate means multiplication. Right? If you are making mistakes in this one, this simple one, and take a good king coconut and hit it in your head. Such simple. AND means multiplication. Ayyo bang. AND means multiplication. Grade 6. What has happened to you all? 1 into 0, 0 ne bang. Ayyo. Right, okay. Altaf first, Chanali second, Abdul Hakim third, Amar fourth, Eduzone fifth. Right, next. Evaluate the expression not 1. Not 1, 1. Another. This is tricky. This is tricky. Not 1, not 1. What is the answer? Very good. Very good. 1. Only 2 gave me the correct answer. See, my logical thinking. See. First, inside the bracket, you have not me. Not 1 means 0. Right? Now, that means inside the bracket, you have 0. Right? So, not 0. Outside the bracket, you have not. Inside the bracket, you have 0 now. Because it's not 1. Not 1 means 0. Inside the bracket, you have 0. So, outside the bracket, you have not. That means not 0. Not 0 means 1. Only two people who have the correct logical thinking here. Altaf is one of them, and Altaf got a good lead of this. What has happened to the other people? Huh? Okay. Next question. In Boolean algebra, which operation has highest priority calculated first? If there are no brackets, what is doing first? Okay, this one is a little bit hard. I didn't teach you yet. I will teach this one next week. Right? Not today's lesson. I will teach this one next week. What do you think? Which one is having more priority? Multiplication or addition? Not. Okay. 6 students gave the correct. Nah, 2 students gave the correct answer. 6 students gave the wrong answer. Not gate has the more priority. Not gate has the more priority. And gate maybe. Not gate. Right. So we are doing not gate first. Yeah. Zain gave the correct answer. Very good. How did you know Zain? From the O levels? Probably from the O levels. Okay. Next question. Get ready. I'm going to give the last question. Last question. What is the result? 1, 0, 0, and 1. What should you do first? O, O, N. One. Nay, you should do the AND gate first. So 0 and 0 means 0. Then 0 or 1 means, or means plus, that means 1. So these things you still don't know. These are tricky questions. General actually. Anyway, I have to teach these parts also. Once I teach these things to you, you will be okay with these type of questions also. Right? So based on this, our champions. Third place goes to Chanuli. Very good. Nice performance. Second place goes to, who's that? Altaf. Altaf first name. Who's the first name? First place goes to Zain. Very good, Zain. Nice performance. Fourth place goes to Amar. Fifth place goes to Abdul. Okay, kids. Okay, okay. Then fine. Then students, wait before winding up. I want to tell you something. Yes, please stay in the meeting before leaving. Haridhar? Right. Okay. Connection is sir. Okay, fine. It's okay. It's okay. Right, students. So today in this seminar, you learned about a lot of things, right? So you revised most of the O-level stuff today. Almost all the things you revised today was O-levels, right? So today's session you learned, we had logic gates. You learned we have Boolean expressions. You learned we have truth tables. You saw some truth tables also, right? But I will teach you, today you learn from the logic gate how to find the Boolean expression. Next week, I will be teaching you from the Boolean expression how to find the logic gate. And after that also next week, I will be teaching you from the Boolean expression how to find the truth table. And from the truth table after that week, you will learn how to find the Boolean expression from the truth table. So today we did what? We did this one. This one completed, right? Lot more to go. Hope everything clear with the today's session, Henang. Henang students, good night, good luck, keep studying, maintain your notes. I will upload the material to the website. You can get the study material from the website. Henang, good luck. May see you next week, right? Okay, bye, sir. God bless you. Good night. Okay, thank you, dear. Okay, fine. So I'm stopping this meeting. Okay, God bless you. Good night.